In Lecture 6b, we're going to provide a brief overview of network layers, terminology that you may encounter when doing data-intensive scientific computing, and have a brief discussion of how security and networks integrate and how that might impact your data transfers. Let's take a look at networking in pictures. In the upper left-hand corner, you'll see a Cat5 or Cat6 cable. This you may be familiar with, whether networking at home or in your office or lab, connecting a laptop or desktop potentially into a networking port or jack in the wall in your office. This is the traditional way of connecting systems. We're going to focus in today's lecture on wired connectivity for large data transfers. Of course, there's another layer of networking we could talk about for wireless, but particularly here for the reliability, for the lower latency, and for the higher bandwidth, we're going to focus on wired networks. Beneath the Cat5 cable, you will see a map of the Internet to network infrastructure topology. When you're connecting in your lab or on your campus, that data needs to transit to all of your collaborators or peers, both in the US and nationally. Internet 2 is a nonprofit organization that connects universities and other educational institutions to help share data and improve education and research. You can see that there's specific hubs in some of the larger populated areas of the country. So we're moving from Chicago to Texas and New York and Los Angeles and the upper Northwest around Seattle and Portland. As we're moving between these larger nodes, we have what we call regional networks that will connect the campuses to these core hubs or these nodes on a large national network such as Internet 2's network. A regional network in this example might be iLight in the state of Indiana that connects Purdue and IU and Notre Dame to Internet 2 hubs, whether that be in Chicago or in Indianapolis. To the right, we have a grouping of pictures, and we'll start, while we're looking at national topology, we'll look at, fiber optics have to be connected, or that network has to be connected across our country. And so those wires have to go somewhere, those cables have to go somewhere. So typically they're run along roadsides or railroad tracks or those other highway infrastructure that we might find in our country. The pictures below that, one is specifically a core router with a bunch of fiber optics, specifically on the bottom half of that picture that sort of looks like spaghetti in the lighter blue cabling. Those fiber optics connect into the core switch there. And on the top, we have that Cat5, Cat6 copper cable. So we have both of those going in. The fiber optics require an additional conversion because optical is not the native physical language of servers and switchgear. It's electrons. So the copper is moving in on the top there with electrons. The optics are moving across and have to go through a transceiver to be converted into an electrical signal. To the right of that is another type of cable that you may hear about, and this is an InfiniBand cable. This is for high-performance computing, and these cables are exceptionally low latency. We'll talk a little bit about the differences between latency, bandwidth, some other terms here in a moment. And last but not least, that core network infrastructure, which we talk about when we say switchgear and routers. There's a picture there of a number of routers and switchgear, and you can see that there's lots of ways to configure them and optimize them, such as you can connect for specific density of ports, we can connect for specific reliability and failover, and lots of other ways that we might try to optimize the network for particular commercial or end user or research purposes.